Hi, I'm Scott Knockleby. In this video, we're going to look at some additional examples of assigning modified D&H parameters. So by the end of this video, you should be able to assign modified D&H parameters to a robot manipulator. In this example, we're going to look at the planar revolute, perpendicular, prismatic, perpendicular, revolute robot. So we have a revolute joint that's perpendicular to a prismatic joint, which is a translational, which is then perpendicular to another revolute joint. So before we can assign our D&H parameters, we should draw a zero displacement diagram. Okay, so we're going to assign our Z0 direction and our X0 direction. Now by convention, we have Z0 aligned with Z1, so we know that this is going to be Z1 as well. And then when theta 1 is 0, that means it's going to be collinear with X1 in zero displacement. Sorry, X1 will be collinear with X0. We then have this length L1 before we get to joint D2, which is perpendicular to Z1. So L1 here. We'll have Z2 this way. And we're going to have a length D2. That takes us to X2. We know that joint 3 is perpendicular to joint 2. So we're going to have Z3 coming out of the page. And again, in zero displacement, X3 will be here. And then lastly, we're going to have L3. That takes us to our tool. So this will be L3. And then we'll have Z tool. And X tool. All right, with our zero displacement diagram done, we can start filling in our D&H table. So we're going to start at frame 0, go to frame 1, then 1 to 2, 2 to 3, and 3 to tool. So our first parameter is A, which is the distance between Z axes while they're collinear. So this is going to be 0. Alpha is the angle between Z axes measured about X. Well, they're collinear, so that's also 0. D is the distance between X's. That's going to be 0. And then we're left with our joint variable, which is theta 1. Now going from frame 1 to 2. Okay. Well, there's a distance between Z's we know is L1. The angle between Z1 and Z2, all right, well, they're 90 degrees apart, and if you look, that's a negative rotation about the X1 axis. So that's going to be minus pi over 2. Okay. And then distance between X's, well, this is our joint variable for joint 2, which is D2. And then the angle is going to be 0. Right, because it's just a prismatic joint. 2 to 3. All right, Z3 and Z2 intersect, so our A is 0. Z3 is perpendicular to Z2, and that's a positive 90-degree rotation about X2. So that's going to be pi over 2. All right. There's no distance between x's, so that's 0. And then we're going to have theta 3, our joint variable. And lastly, to go from frame 3 to our tool frame, right, well, the Z axes intersect, so that's 0. They are 90 degrees apart, and it's a negative rotation, so that's minus pi over 2. All right, the distance between them is L3, and it's just our end effector, so it's not a revolute joint or anything, so we know that this is 0. Okay, so that is the D&H table. And it's really important that you get those rotations correct. All right, so remember, you stick your thumb along the joint axis, and if it's a curling in, it's a positive rotation. If it's rotating out, it's a negative rotation. So make sure you get those correct, because this is where students often make mistakes. All right, our next example is the Rice 6-axis industrial manipulator. All right, so let's first just draw a schematic of what this layout looks like. Okay, so we would have our base joint, which is perpendicular to another revolute joint, right, which is parallel to another joint. So those are our first 3 joints, and they make up what we call the main arm of our robot. This is then perpendicular to another revolute joint, which is perpendicular to another revolute joint, which is perpendicular to the 6th joint. All right, and then we'd have our tool here. We can draw some joint axes in. All right, so this would be Z0 and Z1. This would be Z2. This would be Z3, and these two are always parallel to each other, Z2 and Z3. We have Z4, Z5, Z6, which is also Z tool. So this layout, if we were to write it out, is an R, perpendicular R, parallel R, perpendicular R, perpendicular R, and perpendicular R. All right, and the reason I put these 3 last joints in a bracket is that these 3 joints intersect at a point here. All right, and they form a spherical wrist for our robot. All right, so this is a spherical group. So these 3 joints are what we call the wrist, and these 3 joints are what we call the main arm. And this layout you see here is a very common layout in industrial robots. All right, so you'll see that quite often. Okay, so just like our previous examples, the first thing we have to do is draw a 0 displacement diagram. This makes assigning the D&H parameters a lot easier. Okay, so for this robot, we're going to draw the 0 displacement as follows. We're going to assign Z0 here. And we're going to have X0 here. By convention, we'll have Z1 collinear with Z0, which in 0 displacement means X1 is here. All right, we know joint 2 is perpendicular to joint 1 and it intersects. So this is going to be Z2. And in 0 displacement, we'll have X2 here. All right. Now there's some lengths in this robot. There's a length F here between joints 2 and 3. And then there's a length G between joints 3 and the spherical wrist. All right. So we can draw a dot there. That's our spherical wrist. And then lastly, we would have a tool length, L tool. Okay, so we're going to have a length F here, and we know joints 2 and 3 are parallel, so Z3 will be here, and we're going to indicate that these two are always parallel to each other, and that places X3 there. We're then going to go down to our spherical wrist, so this is going to be G. All right, and we're going to have Z4 there. We're going to have X4 here. Okay, Z5 is perpendicular to Z4, so we're going to draw it out of the page. X5 will be there. And then Z6 is perpendicular to Z5, so it's going to go down. X6 there. And then we're going to have our length L tool. Our tool frame, the Z-axis is aligned with Z6. So this will be Z tool. And then we have X tool here. All right, and so that is our zero displacement diagram. Now with that, we can start filling in our D&H table just like we did. We're going to start at frame 0, go to frame 1, 1 to 2, and so on. All right. It's just we're going to have more rows now because we have a full 6 degree of freedom spatial robot here. Okay, so starting at frame 0, we look at the A parameter. There's no distance between Z's, so we know that this is 0. They're collinear, so we know alpha is 0. The X's are aligned, so that's going to be 0. And then we're going to have theta 1. All right, from 1 to 2, Z2 intersects Z1, so we know that's 0. There is an angle between Z1 and Z2. It's 90 degrees, and it's a positive. So go from Z1 up to Z2 coming out of the page. That's a positive rotation. So that's going to be pi over 2. All right. There's no distance between x's. So that's 0. And then we have our second joint variable, theta 2. All right. Between 2 and 3, there is a distance between z's measured along x. That's going to be f. They are parallel, so we know alpha is going to be 0. All right, there's no distance between x's, so that's 0. And then we have theta 3. All right, 3 to 4. All right, they intersect, so we know A is 0. To go from frame 3 to frame 4, it's going to be a positive 90 degree rotation between z-axes, so that's pi over 2. There is a distance between x's, which is g. And then we have theta 4. Now, for joints 4, 5, and 6 all intersect. All right. So then we know A is going to be 0. All right. Z4 to get to Z5, we're going to have to do a minus pi over 2 rotation, minus 90 degrees. All right. And again, they intersect at a point, so this is going to be 0. And we have theta 5. 5 to 6, again, they're intersecting, so this is 0. Go from Z5 to Z6, that's a positive 90 degree rotation, or pi over 2. Again, they are intersecting, so 0. And then we have theta 6. And then from frame 6 to the tool frame, well, the Z's, there's no distance between them. They're in the same direction, so that's going to be 0. We're going to have this tool length, L tool here, and it's not a joint, all right, so there's no angle associated there, so that's 0. All right, and so that is the D&H parameters for this 6-axis industrial manipulator. And like I said, the Rice is just a one brand. There's all sorts of industrial manipulators that have this layout.